a square piece of cardboard that's 10 inches on each side. You want to make an open-ended box, and you want to find the maximum value. Now, this is kind of hard for some people to visualize, and one of the things in optimization problems is you want to make a picture. Now, if I have this 10 by 10 piece of paper, piece of cardboard, if I'm going to make an open-ended box, what you have to realize is you're going to cut out corners. Now, when you cut out those corners, can you imagine folding, cut out those corners, imagine folding up each side and you have an open-ended box. It's kind of hard for some people to visualize, but you cut out those corners, you fold the sides, you have an open-ended box if you tape the outside. We want to make the box with the most volume. So, we need to make a primary equation and possibly a secondary. Now, what are we maximizing or minimizing? Right there. We're maximizing volume. So our major primary equation is dealing with volume. Now, if we have a box, what's our volume? Base times width times height. Now, is the base of this box always going to be a square if you're cutting out squares in the corner? Yes. And now the problem is, wait, okay. Let's call this X. Do you understand you're cutting out a square in the corner because it has to be a square in order for it to fold up properly? So, do you understand this new side is going to be actually 10 minus 2x? That might confuse some of you. But this new side, if this is both x, if this is x and this is x, don't you have 10 minus the 2 x's? Won't that be the same for both sides? So, what you have to realize is this bottom square right there, won't that bottom square be 10 minus 2x times 10 minus 2x, which is 10 minus 2x squared? What's the height of this box? Won't the height be x? Because isn't that where you're folding it and bringing it up? So isn't that length and width times the height? Do we need a secondary equation? Is this equation all in x's? We don't need a secondary. Now, you kind of use the secondary because didn't you kind of go in here and replace? I kind of did because isn't this your side? I kind of made one, but I kind of jimmy rigged it because really this should be the sides squared, but this is your side, 10 minus 2x. So I kind of actually skipped my secondary equation and thought about it in the process. Sometimes you don't have to write it down. Sometimes it's good to write the secondary is down. Sometimes you just can kind of picture it and just do your primary. Again, a primary equation should always have one variable. Okay, so if we want to maximize the volume, we are going to take the derivative of this and find out the critical numbers and see which critical numbers are maxes. So we want to maximize the volume. So dv dx. Are we okay deriving by x? Now could we just put v prime? It's kind of the same thing, but let's just put dv dx because x is what we're deriving by. Okay, so we now have the 2 comes out, the 10 minus 2x for the beginning, and then isn't there another 2 from the inside? But then isn't this product rule? Ooh, thank you, that's a negative 2. Now isn't this product rule? So now do we also have an x? Plus, leave the first, and derive the second. Okay, before we set this equal to 0, this is the first derivative. dv dx. Is there a GCF? Won't that be a lot easier if we pull out a 10 minus 2x? And then won't that leave us with, what, negative 4x? Looks like. And here, doesn't that leave us with a 10 minus 2x? Is that a lot easier than doing a whole bunch of FOIL? Because aren't we going to do zero product property? Aren't we going to be setting this equal to 0? So isn't it easier to pull out the GCF because you need that anyways later? So what we now have is we have 0 equals, oops, this should be in parentheses, shouldn't it be? That's pretty important. That's very important, actually. That's in parentheses. 10 minus 2x, and then what's inside of here? Is it, what, 10 minus 6x? Is that right? Could we pull a GCF of numbers out? Yeah, but it's not really that necessary. 0 equals 10 minus 2x, and 0 equals 10 minus 6x. If we solve that, that one's going to be, what, negative 10 divided by negative 2, is that 5? Is that right? That's 5, and then this one's going to be 5/3, which is 1 2/3. Okay. Now, those are our critical values, critical numbers. 5 is stupid. Think about it. If x is 5, think about the box. If you cut out 5 this way, 5 this way, and the whole thing's 10, what do you have? Think about the box. If x, go back to this box, x, if that's 5 and that's 5, doesn't that get rid of the whole entire box? Aren't you cutting the box into 4 pieces? I like to fold that up. It's 4 pieces now. That's not going to work. So right away, is this one kind of dumb? Think logically about your answers. Sometimes the answers aren't even in the domain. They won't make any sense. 5 is not part of the domain. Got it? Now, could we cut out 1 2/3? Could we go up here and cut out 1 2/3 and still have a box? Yes. So most likely, this is going to be my answer. But how do we verify that? We do either second derivative test or first derivative test. We want to make sure this is a what? A max or a min, right? Don't assume it is. Most likely it's going to be, okay? But we want to make sure